All right, so we're going to be going through the line of best fit unit, which is the second to last unit in the statistics portion of the year. It's pretty easy. We're going to go through it pretty quickly. Most of what we're talking about is going to be what's called correlation. So, if you're given 2 points on a coordinate graph and asked what line connects those 2 points, it's not tough to do. So if we wanted to determine the equation of the line connecting the points -1, -2, and 5, 6, you would plug it into the equation y minus y1 equals mx minus x1, and you would get down to an equation of y equals 4/3 x minus 2/3. Hi, Miss Owens. Get to the office, Jackson. Okay, so this would be our equation. It's not tough to do. You'd figure out the slope, plug in some numbers, and calculate it out. It gets tougher, however, when you have things like this, where the points aren't all in a nice line. These are actually what we call scatter plots. And in this, you can't draw a single line connecting every one of those points because you'd have all kinds of crazy curves and stuff in there. Okay? No one line can be drawn to pass through all the points. Instead, we look for what's called the line of best fit. So you want to figure out what line goes through all these points and fits the best, because there's a whole bunch of ones you can pick through, so which one fits in there the best. The procedure for figuring out which one it is called linear regression. And it sounds super complicated, and we can use a formula to find it, but instead we're actually going to let our calculator do all the hard work. And we'll talk a little more about that tomorrow when we're talking about linear regressions. So looking at those two graphs again, the linear regressions have been done and the line of best fit is put in. So there's one here and one here. They're pretty easy to see. To measure how well the data matches that, we use what's called a correlation coefficient. And that is a lowercase r when we're looking in the calculator. So lowercase r is what we're going to be using tomorrow. Now, there's another thing, just straight correlation. The easiest way to figure it out is if the y coordinates are increasing as the x coordinates go up. So as you go to the right, your graph is getting higher. This is called a positive correlation. If, on the other hand, as your y coordinates and x coordinates are moving up, so x is going up, your y is going down. This is called a negative correlation. And the closer the points are to a straight line going straight across like this, the closer the correlation coefficient is to a positive 1. So the closer the points are to a straight line going here, the closer they are clustered together, the closer it is to 1. So the more correlated they are. So looking at these three examples here, it's pretty easy to tell whether they're positive, negative, really closely correlated, or very sparsely correlated. So this first one here, if you look, as your x is going to the right, your y values are always going higher and higher and higher. So this is an example of a positive correlation. The second one here, as you're going to the right, your numbers are going down. It's getting closer and closer to the axis there. They're moving down. This is a negative. And this last one over here, it's not really going up. It's not really going down. They're not really in a straight line at all. This is actually what we call no correlation. because they're not related at all. You can't tell which direction they're going. Okay? Let's look at 3 more examples here. So the scatter plot below would most likely have which of the following correlation coefficients? So we want to know, is the correlation coefficient positive, negative, no correlation? Are they really close to linear? What's going on? So the first thing you want to notice is that your graph is in fact on its way up. Okay? It's moving up as you go to the right. So that right away eliminates 1 and 2 because those are both negative. And we can tell that this is positive for sure, so we're down to 3 and 4. Now, something that is a correlation of 1 is in a perfect line. And as you can tell from the graph here, all of these points are not perfectly lined up. So that eliminates choice 4. So our answer here would have to be 3, because it's pretty close to 1. 0.875 is pretty close to 1, but it's not all the way there. So the points are a little bit off of whatever line gets drawn. The second one here, which of the following scatter plots would have a correlation coefficient of positive 1? What I would like you to do is try this on your own. I'm going to go through it in class tomorrow. So take a second, try that on your own. And for 3, I'm going to go through 1 and 2. You're going to do 3 and 4 on your own. So looking at this, determine whether the correlation between the following elements would have positive, negative, or no correlation. So looking at 1 there, it says the size of a backyard pool and the amount of water it holds. So think about what that graph would happen. So as your pool is getting bigger, what's happening to the amount of water it holds? Well, the bigger the pool, the higher the water it holds. A small pool holds a little bit bigger pool holds a little more, and it might not be a straight line, but it's going like this in general. So this would actually be a positive correlation. Number 2 there, the weight of a steak and the price it costs. Well, similar kind of thing. As your steak gets bigger, the amount that it costs is going to be going up, right? A bigger steak costs more money. So this would also be a positive correlation. I want you to take number 3 and number 4, try them on your own. We are going to go over them in class. Also, because we are most likely not going to have school tomorrow, on H41, I would like you to do the first 6 problems. They're talking about correlation, what's positively correlated, what's negatively correlated. So do the first 6 problems from H41 that you got in class. I hope you have a wonderful night, and I will see you later.